This is a demonstration of Apparatus 3. We realize we can't get this equipment all over the planet, so we're going to go ahead and just give a quick anatomy lesson for this equipment, run through how samples are prepared. We're going to execute a really short program and then just take a look at how those results are when this is reciprocating up and down. After that, we'll just show how the equipment is cleaned up. So what we have here is Apparatus 3. It's the reciprocating cylinder apparatus. It was designed for extended release testing. That's looking at a drug as it moves and dissolves through the GI tract. Limitation with regular apparatus is having to change media. So this has a number of rows. I've left the evaporation cover off the front just so you can see the rows. These are racks in here. These can be placed into the apparatus, and along with the vessels, they can be moved to different parts of the laboratory for analysis, and we'll talk about that as samples are taken. But the idea here is to present the drug to media and then allow it to pick up, drain, move back to the next row where it was introduced into the next media. So what I'm simply going to do here is to talk a little bit about the cylinders themselves and then how they're placed into the apparatus, and then we'll switch to another view where I'll actually start programming the instrument. So what we have here are a number of cylinders. It starts with a double-ended cylinder that you see here. This is a glass cylinder. It has two caps. It has a upper and a lower cap that are screwed into position, and you can see a screen on the bottom of that one in my this hand. So once the dosage form and the way it's introduced actually is the top cap is just simply unscrewed. A dosage form is placed inside, and then this is screwed up into the dissolution apparatus under this the evaporation cover. Okay, so again, just the components. We have the reciprocating cylinder itself. We have a 300 milliliter vessel, and the reciprocation is done up and down inside that vessel. The parts that you see here, this is an evaporation cover. A splash cover is also known as, to keep, as this reciprocates at a high rate of speed, it will keep it from splashing out and into the other containers. You'll also see an evaporation cover here that will cover up the vessels as the test is going on, and to maintain the volumetric control over the system. Again, I just have it turned away right now just to explain the system. So these are attached. Once I've programmed it, you'll see how it moves up into the next row. I'm now going to go ahead to the program section, and what we're going to do here is actually just enter the steps that are going to be used for the instrument to run. I'm going to enter program by just pushing the program button, and you'll see a flashing number up here which allows me to store several different programs. It's flashing a 4, that's good enough for us, so we'll hit enter. And now zoomed in on this screen, you'll see a number of parameters. I'll explain these quickly. That there is the dip interval, number 1. When I push that, it's going to allow me to enter the rate of reciprocation, and that's in dips per minute, DPM. Once I finish that, there's also a dip time interval. This is how long it will be reciprocating up and down in each of these rows. Number 3 is the drain time. Drain time is after a dip is over, it's going to allow it to come up and rest for a moment to allow any liquid to drip out before it moves on to the next row. Number 4 is a hold dip time. What that means is when it goes to the next row and descends down into the vessel, it's going to sit there momentarily and allow it to fill up with media before it will begin reciprocation. The 5th point here is batch information. This is where I'm able to enter the name of the product, my name, the analyst, also any information that you have, the batch number, lot number, codes that go with it, and also there's a print frequency button. So I'm just going to demonstrate one particular section, just the dip per minute, so you can see how this goes. It says enter set DPM. I'm going to say 25 to here and enter that. and it's going to do that for each row. You'll see this is program for row number 2. I'm going to enter maybe 20 dips per this, and it'll ask for each row. Now row 3, 20, row 4, I'm going to enter 15, row 5, 15, and row 6, I'm going to enter 8. So the next shot you'll see, we're actually going to move on to starting a program, and you can hopefully see how, once I introduce a sample, how these are introduced into the media. We've now moved the drive unit forward, just so you can see how this instrument is set up. I've put some cylinders in here and put a few things in here to represent drug. We don't have drugs to test in here, so I can't really show you a live sample, but we have some beads and things that will give an idea of the capability. I have one cylinder here, and just to really show how a sample's loaded, I'm just going to take some fairly good sized beads here and just place them in the cylinder, and I'm going to put the top cap on. Now, just a note here, this top cap has a screen optionally. You don't have to have it. If you've got large beads or particles, or you have very little media, like this row, I've actually put different media at different volumes in the system. But this one does have a screen in the top, and I'm going to show how it's attached. I simply just raise the evaporation cover and then just screw this in to the holder, very simply. Just rotate it until it's in place, and I like to hold the bottom of it when you're going to start, and what this does, it checks that and the connection here. So a good check before you ever start to test is just to hold that lower the lower cap and just give everyone just a very slight little nudge, and to make sure that they're seated. So now I'm going to go ahead with, since the samples are loaded, I'm going to start this program, and we can zoom in a little bit and you'll see what this looks like. I'm entering my program number, and I have some selections here to start now. That's what I'm going to do. You do have choices of delaying the start. If you want to start this in the middle of the night and samples are coming in the morning, that's fine. So I'm going to hit 1 to start now, and what this will do is to print, and it'll move forward, and you'll now see the cylinders descending down into the media. The covers will stop there, but the cylinders are still going down. And then I put a program in here to pause about 3 seconds, and then it will begin right about now. Alright, so what we're seeing here, I'm going to get out of the way, and what we're seeing here are several different cylinders that have beads. Now, some of these may be a little bit difficult to see, but what we have, you'll see one that's red there in the middle. That is some candy, actually, and it has a nice red color to it, so you can see it's dissolving. I think that's in the 4th position. So there's various volumes here. These are 300 ml vessels, and they cannot run with 300 milliliters of media in it. What you're seeing is actually with the view is that there are different volumes. So whether or not you have a cap is going to be very important. But this will dip for a little while, and then it will pick up and move on to the next row. Now I'd like to talk about sampling. There's several ways to do sampling, but we're just going to go over manual sampling now. The automated system would have probes attached to these covers, and of course there'd be a collector next to it already programmed. But to manually sample, there's several different ways to do this. I can wait until the entire test is over, and I can simply pick these racks up and move to a bench where I can dilute them, filter them, whatever. But to sample, there's a very simple way to do this, and that's just simply pausing the program, which I'm going to do now. I'm just going to push a button, and what it does is it suspends this program for just a moment. It gets these out of the way, and what I'm going to do is go down here and to pull a sample. Okay, I pulled the red one so you can see this. Then I come back once I pulled those samples, and I just resume program. This will go back down into the vessels and continue the test. Okay, so if a sample had to be pulled during the test, you could do that. Otherwise, when the test is through, we move everything out of the way and pull the samples and move on to the analytical portion of the test. We're now going to go through cleaning up. Our test is finished, and at the end of the test, the drive unit retreats to the home position. That's what it's done. And you can see it's pulled this evaporation cover back over with it. I'm now going to remove this to get it out of the way. This exposes the whole deck where all the samples are. We've only run one row for this demonstration. But again, this is what I was saying. You can pick this rack up and move over to a bench top to prepare your samples. And by the way, we've left no water in this water bath just so you can see things clearly. This obviously would have a water bath. All of this is run at 37. But what I'm going to do now is actually there's two things that we really have to clean every time, of course, and that's going to be the reciprocating cylinder. So I'm just going to show how we go in here to get this off. Simply just lift the drive cover up, I'm sorry, the evaporation cover, and I'm going to unscrew this. And this would simply be taken to a wash area along with all of the other ones. The top cap can be removed. If there's a screen there, you can pick that out. The sample, if there's any hull or anything left over that's unwanted, of course you can take that out. The bottom cap just unscrews as well. And if there's a screen there, you can pop those out as well. Of course there's a screen in the bottom. Now the screens have many different mesh sizes. They go from some very small, this is about a 177 micron screen. This is a little bit larger one. This is about a 40 mesh, it's about a 30 mesh screen that's used. They can be propylene, polypropylene, or stainless steel. And of course the samples are quite easy to clean out. So this is again just an open rod. It can be use your standard cleaning procedures for that. And the only other thing is the vessels. Again, if you've sampled during the run, you already have those. You can just simply take this whole rack over to the sink where these vessels can be individually, poured out and rinsed just like you would any other dissolution vessel. And with that, that's really the end of the test. I appreciate your coming to our laboratory today and seeing this exercise, and if of course you have any questions, please don't hesitate to ask us.